going. So yeah, I'll just give you a quick rundown. Welcome to the second Communities of Practice meeting for the Soil CRC for the West. Thanks again for making yourself available. What we'll do is, this is Zoom, so some of you may or may not have used Zoom before, but there is a chat box on the side which I welcome you to use to make comments or share information or ask questions. You can also raise your hand. What we'll do is we'll go through each of you, just give you 10 to 15 minutes to give a bit of an update on what you've been up to. There might be a specific trial that you've been really interested, that's got some interesting results that you want to share. You've heard a talk, some interesting information that you'd like to share, so we'll go through that. And if we've got time, we'll discuss the paired activity, which I've been emailing over the last couple of days, and where we might go to from here in this environment that we're in. And it looks like, you know, we'll be bunkering down and not being able to catch up with each other probably for a few months ahead. So we'll look at organising some more of these sort of webinars and having the opportunity to connect in that way. So I want this to be as workshoppy and interactive as possible. We'll see how we go, and that just gives you a bit of a reminder about where we all are, where you guys are, and I'm out east there. So just a quick reminder about the objectives and why we're here. We've thought about the objectives about health assessments, understanding soil carbon, soil biology, some motivating landholder practice change once we've got all this tech skills up, and identifying some expertise within the soil CRC, and I've been doing that over the last few months and come up with a bit of a table so that we can have a plan going forward over the next 12 months to cover up on those topics that you guys have identified. So that just gives you a bit of a wrap up of why we're here and what our plans are going forward. So I'll stop sharing that now, and what we might do is we'll kick off. We've got, I'd like to welcome Richard Bell from Murdoch Uni, who I think you all met at our first workshop. So Richard's here to, you know, give us some special comments and expertise along the way. And I've also asked Richard to also give a 10 or 15-minute presentation on a topic that he thought would be useful and interesting for you guys to know about. So what I might do is kick off with Richard to give his presentation, and then I'll call on each of you after Richard, and you guys can give a bit of a 10-minute update on a topic. I'm happy for you to share your screens if you like, or if you just want to talk to us about whatever it might be, or and have a discussion. So thanks, Richard. I'll leave it to you. And yeah, like I said, guys, use the chat if you like, and or raise your hands while Richard's talking, so that we can have it interactive. Thanks, Richard.
Good morning, all. Now, can you actually see the screen? My screen?
Yes.
Well, great, because it's not appearing as it normally does when I do this, but the main thing is that you can see it, yeah. Look, Felicity asked me if I'd prepare something, and basically something that I already had prepared that might be relevant, and I suggested talk about sandy soils, very relevant for Western Australia. And the other topic which I suggested, and we could do that at another occasion, is soil compaction. So I work on soils, sandy soils all over the world actually, not just in Western Australia. Most of the photographs shown there are actually from Southeast Asia, Cambodia, Thailand and Vietnam, which also have really bad quality sandy soils like Western Australia. So we have quite a lot that we can share with them, and we do that in various projects that we're involved in. Sands have some very distinctive properties that are different from other soils. Firstly, limitations often come in multiples, so it's not a single limitation that you've got to deal with. There are often many of them. Secondly, they're very poorly buffered, which means that management can change the properties of sands quite substantially and quickly compared to clays. Third fact is that you get better responses to fertilizers on sands if you also add organic matter with them. And we certainly find that in our work in Southeast Asia. Fourth fact is very minor differences in clay can make a really big difference in their behavior. So if you've got a clay soil or two clay soils, and one's got 40% clay and the other's got 43% clay, it doesn't matter. There's really no difference in behavior or properties. But if you've got two sands, one that's got 1% clay and the other's got 4% clay, that's a big deal. It's a big difference. And final point about clays is that it's really difficult to increase organic matter levels in sands. So I'll just go through elaborating on some of those points. So when we talk about sands, we're normally talking about texture classes of sand, which means less than 5% clay, loamy sand, which means 5 to 10%, and sandy loam, which is 10 to 16%. In the Australian soil classification, sands normally fall in the tenosol group, but they're going to be reclassified soon and put into their own special group called the arenasols. And the sand can come from different geologies and in different terrains. So it can come from volcanic and metamorphic rocks like granite and gneiss that have a high proportion of quartz in them. They can come from siliceous sediments or sandy quartz sediments. And we have some of those along the west coast of Western Australia in what's called the Dandaragan Plateau, as well as along the south coast of Western Australia, sort of east of Ravensthorpe out to Esperance. Also coastal dunes and desert sand sheets. All of those can be the origin of the sands that make up sandy soils. But just as the Eskimos have many, many words to describe different types of snow, we have lots of different terminology to describe different types of sands. And in the soil CRC, we're grappling with that currently because we want to be able to classify sands and map them according to how they might respond to amendments with clay or organic matter. So the things that we would like to be able to know is what's the depth of the sand? Is there a clay layer within the profile and where does it start? Is that clay layer sodic or non-sodic? What's the composition of the sands? You can have fine sands and medium or coarse sands. Some sands have a reasonable amount of silt in them. So along the south coast of Western Australia, those sands have a reasonably high silty content based on the geology. There are different colours of sands which can be very significant in terms of their management. In the profile, there may be a bleached layer that is a very pale coloured layer in the subsurface. That's particularly the case in South Australia on their sands, not quite so common in Western Australia. Some sands have gravel layers in them or have a predominance of gravel in the profile, others don't. And some sands show a lot of water repellents and others don't. So Sands ain't sands. There's lots of varieties of different sands, and they are important for management. But we do have lots of sands, and this is from DPIRD's database. These are the big 6 sand profiles, the deep grey sandy duplexes, and that commonly occurs in the so-called Yilgarn Craton, or the granitic sands that make up most of the southwest of Western Australia. Yellow deep sands, pale deep sands. Then we get into the gravelly sands, yellow sandy earths. These are sands that have a little bit more clay in them, so they're more loamy sand textures, even sandy loam textures rather than sands. And then other types of duplex soils where there's a bit more colour in the sand layer. So we're not called sand gropers for nothing in the West. Did you know that we have a West Australian state soil, which is a grey sandy duplex? So this type of soil is one of the most prevalent profile types in Western Australia, where you have a sandy layer that's 30 to 50 centimetres deep, and then a sharp transition into a more dense coloured clay layer. And you can see in the map there, the brown colours is where that particular profile type is the dominant soil in the landscape. But the yellow colours show where it's still a significant soil. So it's that type of profile and variations on it you find pretty commonly in Western Australia. So what are these multiple limiting factors on sands? Nutrients, both the amount and the retention of nutrients, acidity. In some sands, it can be alkalinity. Salinity can be a problem in sands, poor water storage, compaction and water repellence. So in any one sand, there may be several of those limitations occurring at the same time. And so to get best productivity of sands, you need to diagnose and overcome all of those constraints. If you just focus on one, then you're only going to get part of the benefit that's potentially available. So if you overcome compaction and the soil is still acidic in the subsoil, then the roots are still not going to explore that subsoil effectively. And yeah, so that's one of the keys with managing sands, to try and work out what are all of the limiting factors and have some strategy for dealing with most of them, or at least the main ones. Sands are very poorly buffered so that properties can change very quickly. And that's reflected in this figure here, which shows how the pH of a yellow sand has changed through agricultural practices that acidify. So the black line there was the pH profile under natural bush, where at the surface it was getting into the reasonably acid range, but below that the pH wasn't limiting. But even after 20 years of farming that soil, the subsoil is getting down to dangerously low pH levels. We normally treat 4.3 as the cutoff, where most crops are going to be, their roots are going to be damaged. So between 20 and 40 years of farming that soil, it went from being okay with acidity all the way down the profile to having this real choke in the subsurface, which limits the ability of roots to grow through it. It's difficult to increase carbon in sands, and that's because the main factor in soils that helps to stabilize and maintain carbon is the clay. And obviously sands have very little clay, and therefore organic matter tends to burn up and disappear. And this is illustrated in a study that UWA did on the south coast, where they compared 50 perennial pastures with 50 annual pastures, and they predicted that the perennial pastures would increase the soil carbon. What they found was no difference in their study between these two pasture systems. They did some modelling, and they predicted that the accumulation of carbon is occurring, but it's very slow, and it might take 40 years of continuous perennial pasture before you could build 10 tonnes of extra carbon in that profile. So building carbon in sands is difficult, it's slow, you need to have that continuous input of carbon and minimise the disturbance of the soil. There are lots of environmental risks with sands, wind erosion, deep drainage, which contributes to salinity, as well as nutrient leaching. Stubble retention has been a great saviour of sands in Western Australia. In the 1960s and 70s, there was enormous problems with wind erosion on sands, but the advent of no-till farming, where you retain crop stubbles and protect that surface, that has greatly reduced the wind erosion risk. There's also some, I'd say, unexpected properties of sands, water repellents. I mean, most of us grow up thinking that water infiltrates into sands and drains through them very easily, but we have 5 million hectares of sandy soils in the southwest where water doesn't infiltrate into the sand because of these waxy compounds that coat the sand grains. All of the textbooks tell us that phosphorus doesn't leach in soils. And for most soils, that is absolutely true. But on grey sands and pale sands, phosphorus does leach, and we have some of those, and that's contributed to off-site impacts of phosphate fertiliser in estuaries and wetlands. And finally, subsoil compaction is quite a problem in sands. The water repellents, I'm sure many of you are familiar with that, where water beads on the sand and doesn't soak in. And so after rain, you can have these patches of water that just sit on the surface. You take a spade out and dig, you find that underneath the soil is bone dry. And the water repellent sands are generally the ones that have quite low clay content. So here's an example of a water repellent sand from data that David Hall in Esperance provided. So this is a sandy duplex and it's got a sodic subsoil. But in the surface layer, it has the very high water repellence, which is measured by the ethanol droplet test. That water repellence is quite concentrated at the surface. And in fact, if we measured 0 to 2 centimetres or 0 to 5 centimetres in that soil, we'd find that's where the water repellence is most severe. And in that particular soil, it's only got 3% clay at the surface, but in the subsurface, it increases to 40% clay. Across southwest Australia, I think it's something like 5 million hectares is prone to water repellents, and the purple colours are where the severity is or susceptibility is greatest. So in the northern sand plains, the Esperance sand plains, and elsewhere where you've got sandy soils. This is some work that Deeper did down at Darkin, showing the variation in water repellents. So it can be quite patchy in paddocks. In the one paddock, you can go from being very water absorbent to water repellent in the space of a couple of metres. So that leads to this very uneven germination, patchy growth of crops, and uneven maturity, uneven performance of herbicides, a whole range of issues. The water repellent problem is most common where the clay content is less than 6%, but it does vary a bit with the organic matter level. So if the soil has low organic matter, the threshold is a little bit lower. It's more like 3 to 4%. Clay is the threshold for getting increased water repellents. I mentioned subsoil compaction. It's a real issue with in the subsoil of sands. So this is some data, again from DPIRD, soil depth and penetration resistance, where any penetration resistance greater than 2 megapascals will inhibit growth. Even 1.7 can inhibit growth. So you can see that in these 5 different sand profiles, some of them, the limitation is occurring even at 5 centimetres depth and extending all the way down to 30, almost 40 centimetres. And of course, the culprit here is machinery is just getting heavier and heavier. So the plot on the right-hand side shows the stress from the weight of the machinery at 40 centimetres. And you can see from the 1930s to now, it's been getting greater and greater as the machinery has got bigger and heavier. And so that's led to, sorry, I didn't realize I wasn't on the PowerPoint there. This shows it a little bit better. Of course, ripping is a technology that's been around for a long time, but, and that breaks up the subsoil compaction in sands quite effectively. However, it used to be a treatment on deep sands that had to be repeated every 3 to 5 years because the compaction would just reoccur. With controlled traffic and tram lining, we're realizing actually that that's not, it can be avoided. So that's shown in this figure here where the orange line is the penetration resistance in the unripped soil. The blue is the native vegetation on that same soil where there is no compaction. So you can see the big effect of machinery and agricultural operations causing that compaction. If you rip and don't recompact, then it essentially brings the penetration resistance back to the level of the native vegetation. But under the tram lining, and that's what happens under tram lining, in the tram lining or controlled traffic, all the compaction occurs where the wheel tracks are, and that's the light green line there. But under the controlled traffic system, that compacted area is only going to occupy around about 15% of the total land area. So you're sacrificing 15% in order to get good root penetration and lack of compaction in the other 85%. So we've been working on sands for quite a long time, and as many people have, and there are lots of technologies that are being developed for sands. And they work to some extent, but always with sands, it comes back to what is the main limitation of sand? It's basically that there's low reactive surface area of sands. Little clay, little organic matter, and those are the materials in soils that really give it reaction with water and nutrients. And sands simply have very little of that material. So that is a permanent limitation on how sands are going to behave. So that's led us to think, well, why not change the sand permanently by increasing the reactive surface area through adding clays or through adding organic matter that's reactive but doesn't break down. And that's the nature of the project that we're doing in the soil CRC. But farmers have been doing this for 50 years or so in southern Australia. Operations like this, where in a paddock you dig out a pit, you remove the subsoil clay and you spread it. And when you do that, you can see an enormous difference in the behaviour of crops on these sandy soils. So this photograph is taken in Esperance. In the foreground is the natural soil with water repellents and all those other problems of sands. And in the background is where clay's been added to increase productivity. And David Hall ran an experiment down there for about 15 years, looking at the effect of adding subsoil clay. So the high treatments increased the clay up to 6% from less than 1%, and that requires 300 tonnes per hectare of subsoil clay. And you can see in the canola crop what a difference that makes. So over 15 years, what David's shown is that 100 tonnes of the subsoil mixed into the sand significantly increases the yield, but you needed to add more like 200 to 300 tonnes of subsoil mixed into the sand in order to get a really big boost in yield. And there they're getting averaged over a long time, 50% increase in productivity of crops and pastures. And not only that, but the increase in clay from adding the subsoil has increased pH. The soils are storing more carbon. They're holding on to more phosphorus. The clay itself adds quite a bit of potassium, which boosts the potassium levels. And the soils also hold on to sulfur better, and they've got increased cation exchange. So these additions of clay are making a permanent change in fundamental soil properties. So let me finish off. Sands have very distinctive properties, multiple limitations, they're poorly buffered, they benefit from having organic matter added to improve fertiliser responses. Don't ignore the very small differences in clay. A few percent can make a huge difference in their behaviour. But don't be seduced by people who claim they can boost organic matter by huge amounts in sands very easily. It's a difficult task. It's not impossible, but it's difficult and a long-term task. Sands need to be managed carefully because there are environmental risks, wind erosion, deep drainage, leaching, and there are some unexpected properties of sands, some of which we're getting better at dealing with. And finally, if you want to make a long-term permanent difference to sands, then think about re-engineering sands to increase that reactive surface area so that they're more able to react with water and nutrients in the way that other soils do. So that's my little talk about sands. Thank you. Happy to take questions.
Thanks, Richard. That's great. I've certainly learned lots, so that's good for me. There's a couple of questions in the chat box, one from Freya about the organic matter, which I was also thinking about. So yeah, Freya's wondering, should we bother with trying to increase organic carbon and organic matter in sands? Is it a soil health indicator we should be worrying about, or should we focus on other aspects? Yep.
Yeah, Felicity, it was more so when I've been going to a lot of the regen, and we just went to the soil health conference in York and that sort of thing. And what I keep taking away from it all is get that organic matter and that organic carbon back in the soil. Like one of the take-home messages I keep receiving. But then at the Talking Soil Health conference, there was I think she's a UWA researcher. She brought up that point that actually it is really, they have such, like, naturally have such low % of organic carbon, that maybe we shouldn't be focusing on that with the sandy soils as a way of improving soil health. So I was just wondering what you thought about that, Richard, and maybe what are the key aspects, because I mean, we're like a beach here and on our farm, what we should be looking at improving and monitoring when we're talking about soil health on sandy soils.
Look, it's a really important question. I guess what I'm not saying is don't try to add organic matter to sands or ignore it. I'm just saying that to actually increase the organic matter in sands as a permanent change is very difficult, and it requires constant additions. So it's not a set and forget or once off. And of course, one of the best ways that you can keep adding organic matter to sands is to grow more biomass on them. So the better crops that you can grow, then the more carbon is going into the soil, because the carbon has many, many beneficial effects on nutrient availability, on soil health, on root health, and a whole range of things are benefited by having that organic matter in the soil. Even I mentioned the response to fertilizers is better if you've got organic matter in soils. So if you're in a fortunate position of living close to a source of cheap compost or animal manures, that's great, and you can use them, then you probably have to keep using them over and over again, but that will be beneficial to the soil. But if you're like most people, you're a long way from a source of cheap organic matter, then you've got to think about how you're going to grow it on the farm yourself. And I mean, at that soil health conference, we did hear from Nick Jones down at Newdigate, and that was fascinating. Because what he's trying to do is, grow more biomass with biomass crops, with cover crops, with summer crops, all of that, trying to boost that input of organic matter and then
So we should
the only other thing about adding organic matter to sands is that you've got to be aware that you might increase water repellents as well. Now, there was another question about measuring clay. I'm not sure if you're familiar with the hand texturing methods, where you take a handful of soil, you moisten it, you mold it to break down any PEDs, and then you manipulate it into a ribbon and see how long that ribbon forms before it breaks under its own weight. And that's a simple field technique that gives you a reasonably good idea whether you've got less than 5% clay, 5 to 10%, 10 to 15% or more. Otherwise, if you want a really accurate measurement, then you'd have to go to a lab and CSBP, and actually CSBP, they use the hand texturing method as well, but you can ask them to do a lab test for texture.
Thanks, Richard. Any other questions?
I was going to type mine in, but it might take too long. You might have moved on by the time I'm finished. So I'll just ask Richard. Might be a hard question, but what's the return on investment for claying? And is there, I mean, again, it comes back to that distance, I suppose, of where the clay is, if it's on the paddock versus if you're transporting it a long way. And what's the sort of, do you have a rough idea of how widely it's been adopted?
Okay, David Hall and I and David Davenport in South Australia estimated that probably 200,000 hectares have been treated with clay across southern Australia. So it's a reasonably large area. You can increase the clay in two main ways. One is through what's called delving, where you've got what looks like a big ripper that digs into the clay and lifts it up into the topsoil. But that only works if the depth to clay is quite uniform and about 50 centimetres, 30 to 50 centimetres deep. And South Australia has a lot of land like that. We don't have so much land like that. So the way in which most farmers are adding clay is, like in the photographs, you scrape off the sand in a paddock, and then you dig out clay down to perhaps 2 metres depth, and you spread it in that paddock. And farmers doing that would rarely spread the clay more than about 2, perhaps up to 500 metres. So the pits have to be scattered around so that you're not transporting the clay too far. If you're transporting too far, then the cost starts to blow out. Return on investment, it can be, with delving, it's a couple of years. With the digging it out of a pit and spreading it, it's more like 5 to 7 years return on investment. So, and that's obviously a impediment to a lot of growers. You've got to fork out quite a bit of money and wait to get the return. But as far as we can tell, it's pretty much a permanent improvement. There are places in South Australia that were clayed 50 years ago, and the clay is still there and still providing a benefit. So, and I guess the final thing would be the quality of the clays. So the clays that we have in subsoils in Western Australia are mostly kaolin clays, which are not really high quality clays, but they're better than nothing. In the soil CRC, we'll be looking at some high quality clays where you might be able to reduce the application rate. So from 300 tonnes to perhaps 30 tonnes. So then the transportation is not such a big impediment.
Great, thanks, Richard. There are a couple of there are some more questions in the chat box, but I'm just conscious of time, so we might keep moving on. But Richard, if you could have a look at those questions in the chat box and perhaps answer those as we keep moving along. So I really appreciate your input. So I also forgot to say that we'll break at 12:30 because I know you guys will be looking for lunch at some stage. So I just thought I'd give you the heads up. So we'll keep going till then, and then we'll have a half-hour break at that point. So what I might do, Peter, I might call on you, Peter, if you would like to give share something with the group for starters.
Yep, sure. I've got a PowerPoint and it's basically the presentation, so I'll share it now, I hope. It's the project that we've been doing for the last year, which Richard's probably a bit familiar with because he came down and spoke at it. So yeah, and it's thanks for choosing me first because it's probably fairly relevant to what Richard's just talked about, and tell me how well this is sharing. This is, I don't seem to be going to full screen mode. Oh.
Yeah, so it's just.
There we go.
Oh, there we go. Yeah.
Yes. Okay, so this was a project which we called looking at soil constraints in southwest beef pastures. So you can see the areas that we sampled. We found 24 farms. So we went sort of as far east as, I guess, Pemberton down the bottom here, as far south as Pemberton. Along that line, that's Wilga there, and then sort of Kirrup down to Nannup in the middle there, and along the coast down to Scott River. Funded from the federal government through Smart Farm small grants. So the idea behind it was that a lot of people in the beef industry or in that area don't really do a lot of sampling of constraints. They tend to just do the 0 to 10 centimetre soil test and don't do a lot more. This was a survey we did before an event we held in February, which gives you a bit of an idea that, you know, less than half tissue test, nobody really tests deep, or, you know, 20%. These ones were a little bit high. Compaction, they said that about 50% said that they check it, whereas another test we did with the host farmers was a lot lower. It was more like about 20%, and checking nodules as well was probably a little bit lower. So we really wanted to answer the questions that I had, which was, is subsoil acidity an issue in these soils and land uses, which is a permanent pasture land use? Is compaction, nodulation an issue? What are the micronutrient levels, given that a lot of people don't tissue test, and are there other unknown constraints that we're not aware of? So, and I guess in the process we tested a lot of tools, and it was a good learning experience for me, doing a lot of this stuff. So one of the first recommendations we had was I wanted to sort of, I guess, do enough sites but not have to travel too far. So I did 2 sites on each farm. And within each site we had 2 transects, and we tried to pick a poorer site and a better site to compare it to a better site, and it's basically like a paired
When we talk about
sample.
but we are
Somebody's music's coming up.
Sorry, that's me. I'll turn off my mic. No, I was looking for a YouTube video on hand texturing.
Oh,
I'll do that silently.
Yep, soil testing down to 30 centimetres. So we bought this dig stick, and that was helped a lot getting the deeper soil tests. We did the water repellency test, which Richard was talking about, the molarity of ethanol droplet test through DPERD in Albany. We tested dispersion. We did tissue testing just at the subclover, which is the more sensitive species in the annual ryegrass clover sward. We did compaction analysis. Again, Richard sort of covered that with the penetration resistance with a digital penetrometer. And we dug up subclover roots and gently washed all the soil off painstakingly, and had a look at the roots and the nodules was I guess the primary sort of aim of that. We also cut some of those roots off, the finer roots, and sent them off for mycorrhizal fungi analysis. And then we did, at the end, we did a little bioassay analysis with some seeds, using some of the deeper soil to try and clarify whether aluminium was an issue. The diagnostic pairing, just very briefly, didn't really work for us because it was a 1-year project, and we went and sort of selected sites in April, where there wasn't much grass growing. And I think diagnostic pairing works a lot better when you pick sites during the growing season, probably more in spring, where you're starting to get deficiencies pop up, and you can sort of target that particular area, and then find another area right next to it that's growing well. It's probably a better use of diagnostic pairing. And also the tissue, the texture occasionally looked a bit different between our 2 sites. So, and that may have explained why there was poor production. And it's interesting, even just digging a hole and looking in, you sort of think, oh yeah, this looks about the same soil, but actually getting it in a bag and having a close look at it, and you can see, like, quite often we actually had a compacted site and one that was less compacted. And when you looked at the soil in a hole, it looked exactly the same. When you bored it out, you could see that one was actually a lot finer textured. So these are some of the results that we got. My screens are sort of a little bit in the way of this, so I can't really see everything. But so subsoil pH, you could see that it tended to decline with sands in that 10 to 20 centimetre layer, but then possibly increase a bit as you went deeper. So it was just that 10 to 20 centimetre layer where it got down to an average of 4.4. And the clays seemed to be a lot more stable at depth, or as you went down the profile. But some of those clay soils were quite low as well. Some of them were down to 4. Some of the, I'll show you in the next slide actually, the distribution. But I guess that raised the issue of, well, is aluminium a problem you know, if the average is about 4.4 in the sands, and how well rhizobia, or how poorly rhizobia is affected, given that with the subclover group C, it prefers a range of 5 to 8. One of the questions I've got there is this independent of aluminium? So I've spoken to Steve Carr about that, and he suggested that it's actually like I don't remember his exact words, but it was almost like a hydrogen ion toxicity that can affect rhizobia as well as aluminium. So it's not necessarily just the aluminium, but if Richard, if you could confirm that, that would be great. I sort of hate to sort of rely on one source of information. So this was the distribution, which was interesting. Obviously the sandy soils, as Richard sort of mentioned, probably don't buffer pH as well as the clay soils do. So you were getting a lot more below that 4 compared to nothing really below 4 in a clay soil. And then again, you know, even at the higher extremes, I guess they were able to increase their pH more easily compared to a clay soil. So the organic carbon dropped with depth as well in both soil types. And so, you know, the argument is that aluminium toxicity is detoxified by soil organic carbon. And so, you know, is it a problem in our soils, given that we've got quite good carbon? About the lowest, we did actually get down to about 0.1% at depth in a really sandy soil, which had pretty low organic carbon in the topsoil as well. So yeah, I guess the question was, well, you know, it does drop down to an average of about 1% in the subsoil. So is that low enough to actually for aluminium to start to be a problem? We decided to do these bioassays where we grew some seeds in some of this soil to see if the seeds would produce roots or whether they would get trimmed off. And the roots weren't trimmed off. And I guess talking to some people afterwards was that where this has worked, this bioassay has worked, it's been very, very, very low organic carbon to the point of practically not being any, and then very high aluminium levels. So we measured the aluminium at 3.75, which is sort of should be toxic to sensitive species such as barley, which is in that picture. But yeah, the tests that DPIRD actually did, where they had all their roots trimmed off, I think had about 15 megagram per kilogram of aluminium in them. These are the results of that actual soil type where these plants were grown. And one thing that has sort of stumped me a bit was when we went out and did our cation exchange, and we got exchangeable cations, including aluminium. Quite a few of the soils had quite high exchangeable aluminium. You know, this one had a 60% exchangeable aluminium. Whereas when we went back and sampled it, and I must admit it was a different time of year, so it was, the first one was in April, this one was in January. It was also a different implement, but the results were a lot lower. So I'm not quite sure why that happened, but it's just sort of, I guess, the use of aluminium tests, are they reliable, especially when you're doing it where there is a fair bit of organic matter in the soil, would be another question I have. Tissue testing and micronutrients. So again, we wanted to sort of find out whether there were any, you know, significant deficiencies in micronutrients, given that a lot of the beef guys don't tissue test. And the one that sort of, well, one issue that we came out with was we started this, we had to cover 24 farms. So we started in late July and went through to September to cover all the farms. And quite often, you know, late July, early August, there hasn't been a lot of growth, and so some of the deficiencies don't show up. So I guess one of the big learnings from it was to just try and sample probably from around about the start of September, in those first few weeks there where the growth has picked up and deficiencies are starting to show up because they're starting to use up all their nutrients. But molybdenum did appear deficient. So the general cutoff is around about 0.1 to 0.2 critical value of molybdenum. So we can see that we had 22% of sites that were below 0.1, and then another 16% that were between 0.1 and 0.2. And that was the main element really of all of them that came out as deficient. And I guess in some cases you can just apply copper and zinc without molybdenum. And so whether people are doing that, and also I think Richard was saying with this presentation, you know, sometimes a copper zinc application can be in the soil for 15 to 20 years, whereas the molybdenum appears to sort of be there for 5 to 10 years. So they might need to sort of apply it a bit more regularly. In some cases, I think people just hadn't applied it at all. So that would seem to be the main thing, rather than not applying it regularly enough. One of the key things from that as well is that you have to ask for molybdenum in your tissue test. It doesn't come automatically. We also had a few sites that were low in phosphorus and some low in potassium as well. Trying to whip through this as quick as I can. So soil compaction, we basically did what Richard described earlier, with that 2,000 kilopascal limit, where we rated the paddocks. Basically, if we had, with each site, we probably did about, what was it, about 12 to 15 insertions per site. So if 75% of them were over 2,000 kilopascals, we rated that as severe, and if it was 50 to 75%, it was moderate. So you can see the clays seem to have a little bit of a compaction layer, relatively shallow, you know, coming through at 5 centimetres, but then not really getting any higher at about 10 centimetres and then declining, whereas the sands, you know, at 5 centimetres they weren't too bad, but quite often it's around about that 8 centimetre, 8 to 10 centimetres where the compaction really kicked in and didn't really seem to decline at all. And we compared that with fence lines, and most of the time, this is a combined fence line, so it's not, this is for sandy and clayey soil, but, you know, you can see that the fence lines are typically a lot less compacted. So yeah, and there's certainly no controlled traffic farming in these environments, and people just sort of go all over the place over the paddock. They might not have necessarily heavy machinery, but they're, you know, driving around on wet soils quite often to spread out, you know, feeding hay and that, you know, throughout a lot of the winter period. Some shortcomings with the penetrometer was that it didn't really capture the earthworm beetle pores, evidently, so I've read, which is interesting because a lot of those clay soils did seem to have a lot of earthworms. A lot of the sandy soils didn't really seem to have many earthworms. We didn't see them when we dug holes anyway. The finer soils, as I said, seemed maybe more compacted. So I guess the question I had from this was, well, what's the best treatment to what depth? And does your level of ripping and that sort of thing, is that affected by what nutrients are at those depths? Because this slide here shows that, you know, when you got down below 10 centimetres, the nutrients sort of dried up fairly quickly. Sulphur was fairly good, really, in the top 10 centimetres, but, you know, 10 centimetres lower, and you're looking at about 50% of sites had less than what is considered a rough critical level. Didn't really get any worse as you went deeper. Phosphorus, this was based on a maximum yield, so it's a combination of coal, phosphorus and phosphorus buffering index to come up with this level. And again, you know, about 50% of the sites are below 80% maximum production in the subsoil. And then potassium was a really interesting one, big difference between the two soil types, where in a sandy soil, the potassium was quite often moderate, so it was, or marginal, should I say. But getting below that depth of 10 centimetres, it was quite often deficient. Whereas in clay soils, it wasn't as bad. And the one thing that stood out with these, with this survey, was that a lot of the clayey soils had way too much potassium. They had really, really high potassium. So I guess, you know, with so much potassium, that was sort of getting through to the subsoil, whereas the sandy soil is probably leaching a lot of it, I would assume. But it does bring in, you know, the whole regen ag question of, let's get our roots deeper. Well, you know, will they go deeper if there's no nutrients there? And sort of how do we deal with that? How do we, you know, how do we incorporate these sort of results into regenerative agriculture? And getting deeper root systems. So that's a question there, and another question I've got to consider. So I'll just quickly whip through what else we did. We did the nodulation. We dug up about 403 plants, which wasn't much fun, washing them anyway. These are the results we got. So this was a scheme, I guess, to assess or score the nodules. So we found that on average, probably about 38% were moderately, nodulating moderately, which is fairly conservative, I think. So it's roughly around about that, 11 to 20 small pink nodules per plant. Again, seasonal variation here where it seemed to increase a little bit through the season, so it's probably better to sample that in spring. We checked this with Neil Ballard. We sent him 43 photos, and our sample average was 4.3 on those samples, whereas he averaged, 3.4. He averaged 2.4 when he looked at the same samples, so perhaps we were overestimating a little bit. So it's a fairly conservative estimate. The one sort of, I guess, thing that we weren't expecting to see was a lot of root disease. And the same 43 images I sent off to Martin Barbetti at UWA, and he characterised about 2/3 of them as having severe root disease. So you can see the roots just getting trimmed off here, and darker roots. And his thought was that will have a pretty big effect on nodulation. This one here is a problem there where he said that root system, the whole lot of this root would have collapsed about 10 days after that photo was taken if we had kept it in the ground. So it's a complex of several fungal diseases. So it's not just one disease, it's Phytophthora, Pythium, Phanomyces, and possibly Rhizoctonia as well, and possibly a few more to it, but they were the main ones. He's trying to find resistant varieties, but it's difficult when you've got so many diseases to find a resistant variety. However, he did find cultivation to 10 centimetres was effective. But, as I guess, people that we are and, always talking about soil carbon, we tend to stay away a little bit from cultivation. But, perhaps in this system of permanent pastures where there isn't much cultivation, there's, not a lot of incorporation of lime, is it something that we need to think about a bit more? Very quickly, water repellents, yes. I think we had about 76% of sandy soils were severely repellent, and that's about with that test that Richard was talking about. They generally within that 2.3 to 3.5, so quite often around about 3, 2.8 to 3. Won't dwell too long on this. We didn't see much evidence of dispersion. And a vascular mycorrhizal fungi, medium colonisation was about 76%, and there seemed to be a correlation with tissue phosphorus. So a lot of the research and I guess theory is that AMF has a relationship with phosphorus. So where there's less phosphorus, it will be more prevalent. Where there's lots of phosphorus, it will be less prevalent. And our tissue test results seem to sort of show that the trend. That I have done some stats, and it, based on my poor statistical analysis, it did seem to be quite significant, but I need to get that checked before I really talk much about that. So summary, everything basically pointed to low subclover productivity, where you've got poor nodulation, subclover disease, pH that's below rhizobia preference, low molybdenum, which is required for nodulation, which is probably due to poor application, and also low pH, and compaction that may exacerbate disease, where really the plants need to grow away from that topsoil area where the disease sits. It sits in that organic layer. So if they can get down below that, then they tend to sort of are more resilient, whereas if they get caught in that top level, then they probably suffer a bit more. So the tools that we've sort of found quite useful was deep soil testing, just to sort of see your subsoil acidity, but also, what nutrients you've got at that depth. and then maybe a repellency test, which can be pretty simple as just pouring a bit of deionized water or even regular water on the ground, not having to do that MED test all the time. Assess clover growth in autumn winter just to see if there is an effect, and quite often it shows up with a disease. It shows up at that time, and it can look like it's a phosphorus deficiency where the plants are small. So having your soil test there and comparing that and saying, well, could it be phosphorus? If you've got very high phosphorus in the soil, then chances are, well, maybe it's not phosphorus, maybe it's actually a disease issue. And then come along back in spring and have a look at the roots. Assess compaction, wash the nodules, and maybe do a tissue test at that time of year as well. So I guess my questions are, is strategic cultivation potentially beneficial in that land use type, and do we need to hold nutrients deeper? How do we do that? So that's the end of me.
Thanks, Peter. That was excellent. That looks like a really interesting project as far as all that monitoring that you were doing and being able to draw those comparisons out. I've heard a lot about strategic tillage lately, particularly in regards to compaction, and I think there's also it's in regards to compaction, but also movement of lime. I think New South Wales DPI have done a lot of work on lime rates and the very slow change of pH. And I think, they're coming to the conclusion that either the rates haven't been high enough or it's just not moving through the soil profile as they would have expected. And so maybe there's some opportunities there. As much as the whole deep ripping does concern me, and I'm sure Richard's got some comments about it as well. I think you just need to be really careful about what is underneath and that you're not bringing up. I mean, I guess I'm comparing it perhaps a bit to delving, which is sort of inverting and bringing the clay up to the surface, which has been done a lot in Western Australia. But deep ripping, the risks of bringing those subsoil constraints up to the surface and mixing sort of good and poor soil together. But yeah, if anyone else has got any other questions or comments, Richard.
I should, just before you do, the recommendation from Martin was that, about cultivating every 5 to 10 years seemed to have an effect. So he didn't seem to think you needed to cultivate any more regularly than that.
Mm-hmm.
Yeah.
Yeah, good. Yep. And I guess I'd just, go Richard.
Yeah, look, it is a great project and case study that sort of illustrated quite a lot of the things that I talked about. Just a couple of comments. One is, Pete, you're working in high rainfall environment. So that means you've got a lot more organic matter at the surface because you grow more biomass. And so that organic matter reducing the aluminium toxicity is something that may be happening in your area, which may not be an issue as you go further west and north into the drier areas. Secondly, great value in subsoil sampling. The tradition is 0 to 10 centimetres, but there's a lot happening at 10 to 20 and 20 to 30 centimetres with acidity and nutrients that we just don't know about because not many growers are doing that deeper subsampling. So I think that's one of the next challenges in advising growers where to go with trying to increase productivity. Look deeper and do more subsoil testing. The rhizobium and hydrogen ion toxicity, yes, that's they can be damaged by acidity without aluminium. The exchangeable aluminium test is probably not the best one. The calcium chloride extraction for aluminium is probably a better test. Yeah, I think those are the main points that I thought were worth commenting on from the presentation, but great presentation.
Thanks,
Thank
Richard.
you.
Can I ask a question, Felicity or
Yes.
Peter? Hey, Peter. You measured AMF and the relationship it had with its phosphorus, isn't it? And my understanding is AMF sort of makes, you know, if there's not phosphorus readily available to plants, the AMF will create the plant and AMF work together. The AMF sources that hard to get at. Phosphorus provides that to plants, and then the plants then feed the AMF with carbon or their, you know, whatever is left over from what they do. And I don't know, I just wanted to, you know, is there anything else? Because it seems like you measured AMF, but were there any findings related to that in terms of, you know, where there was higher levels of AMF, was the clover more healthy, or was it, you know, was there any correlation at all with soil health that you could see?
Not really. No, I didn't really do enough, look at it closely enough, and I would have liked to have, you know, hadn't expected the disease. We might have been able to have a closer look at that. The one thing that sort of stood out to me was, and this is very, you know, this is very anecdotal information. The one site that had the lowest AMF, he had the cleanest roots that I showed Martin. So he had the least disease. He also had the lowest phosphorus. And the sites that tended to have more AMF, I guess, I've just a bit of a theory that, you know, there may be something to do there with the disease. There's some sort of interaction with that, in that if the plants are, I guess, losing their root systems, that they might benefit more from an association. It may also be that they're actually losing their root systems because they're getting invaded by, you know, pathogens, and in some people would view AMF as a pathogen. And they put out signals, evidently put out signals, you know, to find associations with different pathogens, and whether that, by putting out that signal to AMF, you know, that actually invites the actual pathogens to also colonise and destroy the roots. It's a very complex arrangement, but to me, basically, at the end of the day, it just said, well, look, AMF isn't really, you know, a silver bullet as a, you know, soil health test, you know, because there could be something else going on, and it may actually be telling a completely wrong story. So, yeah, and just speaking to the couple of the researchers, you know, it was very hard to get a straight answer from them. You know, like, they've done a lot of research, but you know, they can come up with nice trials in a university, but when it comes to going out and looking at relationships in the field, they very rarely see any. And in fact, Daniel Kidd, when he looked at this data, he was very surprised and happy to see a relationship from a field experiment, which he's never seen before. So many interactions. I guess that's one of the outcomes of this project, was there's so many interactions going on, it's hard to find correlations with anything. Yeah.
Yeah, the more I go as well, the more I learn, the more I know I don't know. And farmers don't know, and yeah, there's a lot to learn.
Great, thanks, Peter. We might move on, and if anyone's got any other questions for Peter, please pop them in the chat. Yeah, so Freya, are you happy to go next? Are you ready to do that?
Yeah, I don't have a snazzy presentation.
That's okay.
Or anything
That's
like that. Yeah, so mine will be much shorter. I was just just going to give a bit of an update on one of our projects, which is one that Wendy Bradshaw, who's on our committee, is sort of running, which is the Beaver trial. So it's looking at traditional systems with the knife point stripper front, the knife point seeding over the disc seeder stripper front, and looking at stubble retention, soil moisture, and hopefully changes in soil health. So we've got one trial in Bocal, just near Arthur River, and SWIC's actually funding the analysis, the nematode analysis, I think. And yeah, so Wendy's just writing up the proper report right now, but she did present at the Soil Health Conference. We've just done the first sort of year 1 results on that site, which you can imagine there's not a lot, you're sort of just getting that baseline, so there's not a lot that's come from it yet, but what was really interesting is that the non-wetting still seems to be the major, I guess, impact or constraint on yields, but the farmer was really, really impressed with the germination on the disc seeder because of the moisture retention around the seed early on. He did have trouble though reseeding with the higher stubble. So we're thinking of either just putting more weight on the disc seeder or baling up some of the stubble as hay. So kind of looking at those different things. But what's quite interesting with the way that we're running this trial is that it's just like a farm-based trial. So it's not got controlled, it's, over a paddock with varying soils. So yeah, it's really interesting. You're not trying to control all factors and change one. So yeah, it's just really interesting kind of doing it that way. And yeah, just more of our on-farm learning experience. It's been really interesting so far. And we're actually applying currently for state NRM extension to work with Torbay Catchment Group, as well as a farmer who's just moved into our area nearby in Cranbrook. They all have the gear already. So just looking at trying to replicate it over a few different areas with different soils, different rainfall, and also just the different farming systems and that sort of thing. But yeah, it's been really interesting. The nematode analysis didn't show up anything yet, but we're hoping as we continue, it'll be really interesting. And we were digging some soil, just some holes really, just to see what was going on. And there was lots of earthworms, which is really cool. I don't often see them in the paddock. So yeah, no, it's really good. So Wendy's sort of going to do succession planning and pass the project on to me and teach me a lot of the stuff that she knows about the beaver trial, as well as just all of her soil health expertise. So yeah, I'm really excited. And yeah, we're hoping we can sort of get small amounts of funding, because we don't need a lot because it's the farmer-based sort of system, but just actually getting the money to do the sampling and analysis over a long enough period of time. Because like Richard was saying, sometimes, especially in the sandy soils, the changes are very slow and small. So that's what we're really trying to battle against. I think most groups sort of have that with when we're talking about soil amelioration techniques and stuff. But yeah, that's basically it. We're just in grant writing process at the moment. So that's all I've been up to really.
Excellent. No, that sounds really great. And yeah, that the cost of monitoring and evaluating and all that sort of stuff is there, but it's most important. I'm working with farmer groups and they're telling me lots of anecdotal stuff. There looks like there's more plants and the roots look like they're longer and, that sort of thing. But it's really important to quantify those anecdotal comments and yeah, so that you can really have some robust data to compare to and tell a good story, rather than just lots of "it looked better" sort of comments. So yeah, good on you. Yeah, that's great. Well, we'll look forward to following that through as you go on. Yeah. Richard, do you have any comments about that?
No, I heard Wendy's presentation at the Soil Health Conference. Yeah, really interesting work there. Tell you a little story about Wendy. Wendy was my wife's bestie at primary school at Mount Barker many, many years ago.
It's a small world.
Everyone knows everyone.
There you go. Fantastic. Thanks, Freya. That sounds really great. Marnie, would you like to go next? I can just see you there, so that's why I asked you. And yeah, you can be our one before we have a break for lunch, if you like.
I had a quick question for
yes.
Freya. I don't know how real, I mean, maybe it's not possible, but with the stubble, I mean, the other option could be rolling it so that it's out of the way of the seed. Is that I don't know, maybe it's not.
Yeah, it was sort of an interesting discussion we were having, because we want to, it's like the awkward factor where you want to retain as much stubble as possible for that, for the, just even when he was talking about, we were having discussions about the shade over the soil and all those sorts of things to improve moisture and organic matter. But then the farmer had to cut it for hay in order to be able to seed back into it the following. So yeah, it's really interesting. I think there's lots of stuff we can do with the extra stubble, but then at what point, that's why it's really, yeah, it's sort of strange. At what point are we compromising what we're trying to do, because you can't, seed. So it's been, it's been really interesting. So I think, you cut it for hay, and we've just had to put more weight on the disc seeder to get it down. And the yields, he actually, he did find higher yields in the disc seeder stripper front than in the knife point, but we think that is the non-wetting. That's still we know that that's still the main factor as to why that's occurring. But the germination was really interesting. He said, it came up 2 weeks before the traditional sort of strips. So yeah, awesome. But there's lots of options for the stubble for sure. We just need to, and every farmer that we deal with is going to be different. It's just going to figure it out.
That's right. And then feed is needed and stuff too. So yeah, cool, awesome. I've commenced this year the Regen Ag course at Southern Cross University, and that's why I was so disappointed, Peter, with the AMF, the discovery of what your work was finding or had discovered, because my last project I did a little group presentation with some students. We were looking at glomalin, which is a recalcitrant carbon source in soils that's could be an exudate of AMF. So it looks like it could be potentially a really great way of increasing carbons in soils. What I've seen so far, there is so much of the work is done in places where there's actual soils, not just sandy soils. So translating it to Western Australia and, the soils that we have to deal with is interesting. And I did the project with people that are farming in, on bigger farms in drier areas than me. And so, we talk about the importance of, and I think, Peter, you said, in regen farming, it's all about the length of the roots, and they're going, further and further into the soil, this wonderful soil. But sandy soils, you're meant to be maintaining cover all year round, and in a dry environment, it's very hard to do that. So, and even down our way, we had a bit of dried clover on the sandy soil, and that's it for summer. It was so dry here. So the course has been really interesting. I mean, a lot of it is about, introducing me to science for the first time too. So that's been good. And I guess for me, because our organisation doesn't do specific, projects on soils and things like that. But I know I've hooked up with Freya to do a hydrophobic soil sort of project, because a lot of our growers just had a terrible time getting anything to germinate or grow over this last season because it was so dry here. So, and they're dotted all over this Great Southern, the Southwest, and I think there's some further north as well in Moora and places like that. So we're really keen to develop a industrial hemp seed that can cope with the dry environment here. But we really need to be able to help our growers make sure their soils are in the right condition to be able to grow stuff too. So, that's why we're sort of focusing on that. So, but I don't have any, other than this fascinating thing called glomalin that I discovered. I don't really have anything specific that's sort of soil related, but so I guess that's it from me. I don't, because is that okay?
Yeah, that's fine. No, that's good. It's interesting to hear what you're up to. Do Do you know Anne Coote? She is also, I think, doing the the Regen Ag, or the Bachelor of Science Regenerative Agriculture. So Anne is a member of the Northern Communities of Practice group for soil CRC.
Yes, I've been seeing her name a lot. She's very active in all of the discussions and very knowledgeable. So yeah, she's been there. And what the other connection I've noticed is there's the course coordinator is Hannah Beth Luke, and I think she's actually been presenting. She's presented at the soil conference, so which I have not yet seen all of. So, but yeah, so there's been some lovely connections between the soil CRC and the course. So, and that's been really good. And having the farmers that are on the ground doing, saying, well, this doesn't work, that, it doesn't work, and how you being quite critical. So it's really good, robust discussion that we're having. So yeah.
Yeah, great. All right. Well, thanks, mate. It's good to, for you to share so that we can hear what you're up to. And I guess I'm also conscious of thinking about the work that you guys are doing and what soil CRC researchers are doing and what is relevant to what you're trying to do with your groups and your growers and your landholders. So I have put together, and I think it was, that list of projects that went out to you guys with the opportunity to work together on a little project. So just with what we've covered off on the so far this morning, there's Dr. Ehsan Tabakoli from New South Wales DPI. He's doing some work on subsoil constraints, and I think he's also quite knowledgeable in this fungi area. He's done some work with sugar cane growers on working with fungi and that sort of thing. So I think we'll try and get him to come and talk to you guys. There's also the plant-based solutions, which Terry Rose is working on, and you heard from Terry Rose at the National Soil CRC conference. He's doing a bit of that regen ag stuff and working, well, actually, Lucas spoke about Terry's work, but yeah. And he also, there is a video, the Soil CRC videos, and Terry is talking about in one of those videos, which I'd encourage you to have a look at. So yeah, we'll just keep, and also of course, Richard is working on the new amendments for sandy soils, soil CRC projects. So it might be interesting to hear how that's getting along. Richard, maybe if we've got some time at the end, or certainly through the life of the group getting together, and how that's progressing. So it's 12:30 where you guys are, so perhaps we'll have a bit of a break for half an hour. So perhaps we'll aim to come back at 1 o'clock if that suits you guys. I'll keep the meeting room open, so I mean, if you want to go and grab a sandwich and come back and have a chat, or just have a bit of a break, but I'll be sort of hanging around, and if you want to come back and have a chat, but we'll kick off again at 1 o'clock your time, if that sounds okay.
Okay, good.
Recording, as people come back in, they'll catch up. So I did, it was remiss of me to mention the chat box again, so good on you guys. There's a few comments in there, and Richard's made some comments about AMF, so go back and have a look at the chat, and there is a few questions. There's a few questions in there that Richard might be able to answer, and there's a couple of questions there for you, I think, Marnie, so have a bit of a look in that, and we'll keep ticking along. So Belinda has kindly said that she's happy to go next, so share away, Belinda.
Okay, well, my life hasn't changed with lockdown or quarantine or whatever it happens. I've been out and about like there's no tomorrow, so I haven't had a lot of time. but my one thing to, whoop, you see that?
Yeah.
Is what I've been doing my little homework on in terms of regenerative agriculture systems. So it's for the, what is it? For the Love of Soil by Nicole Masters. And I've been reading through that, and I guess in the, now that we have some moisture out there and a little bit of growing conditions where we can do a few little trials, she's actually quite good in setting up some nice, easy, simple to do tests for people on their own farms or at home or whatever else, and things just like, you know, water infiltration rates and counting worms and, you know, getting a refractometer and measuring bricks levels as a way of measuring soil health. Marnie, you'll be happy to know that mentions glomalin or whatever it is in here as well a couple of times in terms of, you know, its effects on soil and how beneficial it is for building soil aggregates and things like that. Yeah, so in the next couple of months, we'll probably be trialling a few of these types of things just on my own place and a couple of my clients' places, just to see, you know, if they can get some measurable differences in soil health indicators. And just, you know, it's kind of simple and easy to understand the way she's written the information, and looking at what are the limiting factors in your soil health and how you can improve them using regenerative agriculture techniques.
Yeah, okay. So, Belinda, you weren't using any of those things before that she had suggested, or?
Yeah, I've been sort of for the last couple of years sort of starting to implement some of these things, but not to the extent, you know, just the simple ones that were easy enough for me to do in terms of soil testing and, you know, applying lime and dolomite and using like biological stimulants, you know, combinations of molasses and fish emulsion and worm leachates and things like that. And we've just been doing in the, you know, because that's just painful to actually have to mix all of that stuff up. We're starting to use just Nutrisoil now, which is a worm leachate come biological fertilizer, and see how that goes. But it's always interesting to see, you know, because for most of the properties that I'm on, they're tending to be small landholder properties, so they don't have a lot of land area, and generally speaking, they have way too many animals. So like overgrazing, bare soils, compaction, all of those kinds of stuff is what's going on. And so to try and tackle that from a grower perspective can be pretty difficult, just because they can't see their way around other ways of doing things, or, you know, maybe having a fence their place a little differently, or, you know, they just can't leave their animals on paddocks wholesale 24/7 because it just, you know, there's no way they can maintain ground cover with that kind of situation. So it's one for me. I kind of like to, you know, with my own place, often I'll use that as a, you know, to hold workshops and demonstrations to people so that they can come in and see the way I manage it. And, you know, we try and find some other properties around the area that are doing a similarly kind of job that do it maybe slightly differently to the way I do it out in my paddocks, so that people sort of get some different options of how they might manage their grazing and their, you know, sacrificial areas and things like that. But then I sort of want to go a bit further, because you sort of get the clients where they're actually doing that quite well, but then how can they improve from there? So the next step on, and trying to do it in ways where you can actually train the person themselves to be able to put a few, you know, dig a hole, and, you know, like you're, you know, talking about the texture test with clays and things like that. You know, they're quite simple things to be able to do, and, you know, bang in a bit of tube and measure how long it takes for the water to infiltrate and things like that. They're simple enough, or, you know, they take a chunk of soil and sit it in water and see how long it takes to disperse, or whether the soil aggregates will stay stuck together. Those sorts of things are pretty simple to do, And, you know, people can go out and do that themselves if they're so inclined, and then we can work from solutions forward from there as how they can continue to improve.
Yeah, great. So will you be using some of those monitoring to evaluate some of the land practices that you're working with your landholders with? You know, like perhaps implementing some new practice, so doing an infiltration test at the beginning and then implementing a practice that you would hope would improve infiltration, and then doing that infiltration test on a regular basis to monitor improvements. Is that the idea?
Yeah, that's the goal, is to get you know, probably just a couple of groups at this stage of people that are interested in taking it further, because that's the hardest thing is, you know, you get people that want to sort of come along, but then they're not prepared to kind of go out and do it without you sort of standing over there or helping them. So it's trying to set up, you know, a couple of little opportunities where they can come, they can see how it's done, and then, you know, go off and do it themselves, and then perhaps, you know, via a Facebook group, you know, have them show their results, and then, you know, then work out a strategy forward of how they can improve on that.
Yeah, great. Does anyone have any questions or comments for Belinda? No?
Yeah. Well, okay, I'll go first. Yeah, what sort of techniques did she, or do you recall that she sort of spoke most about as far as, you know, monitoring soils, as far as, you know, you mentioned infiltration. I've always been a bit scared to do infiltration because evidently the way you bang in the ring, you know, might sort of break the soil enough for the water to slip down there and not actually give a proper representation. But yeah, that's just me, I suppose. But yeah, was there any other particular sort of things that she was monitoring?
So obviously soil tests, just basically some of the chemistry. I'm just trying to find the bit in the back of the book because it's really simple and I don't forget anything. But using so what was it? Yeah. So just a lot of the time she talks about, you know, you could literally set up a metre by metre square in your paddocks, like a number of them. And then, you know, a lot of it is so, you know, in terms of what to apply, a lot of her stuff is looking at just do a little test and use your refractometer to test the change in bricks for the plant, because anything that's going to get your plant photosynthesizing and lifting the bricks level means that the plant will then actively be putting stuff back into the soil and help improve, you know, soil carbon and all of that kind of. I don't know whether I'm explaining it terribly well, but and also the higher the bricks level, the less the plant is exposed to, you know, insects and bugs and attack, that kind of thing. So in these little sort of metre by metre squares, she's like, you know, get yourself a bunch of little squirty bottles, and you might add milk to some water, and you might add salt to some, if it's, say, you know, something that a soil that might be missing sodium or whatever, they might want to add, like, if that may give an improvement in bricks level, or it may be a compost tea or a worm juice or a whatever of those kind of scenarios, and, you know, spray it out. Well, sorry, you do a bricks level reading prior to applying this stuff, then you go and spray the stuff out, go have a cup of tea for 40 minutes or whatever, come back out and measure a bricks reading again, and anything that improves the bricks level is something that she would go, right, now that's worth putting on your pastures and seeing whether that will improve your growth and performance of your plants. But then also the infiltration, basically she's sits there and goes through a range of methods of trying to work out what the limiting factors are in your soil. So infiltration obviously is looking at whether you're getting enough water and air into the soil, and your levels of compaction, I guess, within that. Then looking at whether minerals may be an imbalance, so your soil testing, tissue testing to see. She often does a lot of comparisons between, you know, the weeds that love to grow in your place versus your the actual pasture species you want to grow. So, you know, if you're taking bricks readings and your weeds have a higher bricks level than your, you know, target crop, then something in your soils is actually allowing those weeds to have a better opportunity to grow than the target crop. And so how can you change that to better reflect the other one? And then just different strategies to go through from there of once you've measured it, once you've worked out what your limiting factors are, then can you go from there to put some strategies in place to help improve those. Does that make sense?
Yep, no, that's good. I did see a presentation where she covered that, where she had replicate little 1 metre patches, little squares, and yeah, applying different applicants or applications into different treatments. Yep.
Yeah, and it's kind of fun. Like a lot of people seem to enjoy that sort of science. It gets them back to their, you know, science days where they had a test and a read the result, and it gives you a fairly, you know, it's a short space of time, but it gives you, you know, an indicator of where you're at and what's doing better.
Just going to say, Richard, is a 1 by 1 metre sort of plot set up like that going to be scientifically valid, or should we make them a little bit bigger?
Look, I think the principle is there are lots of systematic investigations you can do. And I think 1 by 1 is probably okay if you're going back to that same area and you've got a control and preferably some replication, then that's the basis of experimentation. I guess you'd need to be aware of or alert to site variability to make sure that the patches you've selected are representative and they're well matched with the control.
That's a question as well. I haven't. I've noticed Peter's got it as well. Is the bricks meter and the use of the bricks meter and the sugar content as being I guess it's a rough estimate of the health of a plant. Is it, or is? I mean, this might be the wrong forum to ask this question, and maybe I should just go look in the library. But do you have an opinion on that, Felicity or Richard, on that sort of approach to? You know, evaluating the effectiveness of treatments?
You can go first, Richard.
Look, I'm not really familiar with its use, but I mean, the principle is, as Belinda explained it, it's when plants grow better and photosynthesize, they produce sugars, and bricks is a way of assessing that in the plant, but it's a question of the sugars will tend to be used fairly quickly in order to produce more biomass. So I don't know whether it's just a short-term response or whether it's the long-term response, but yeah, as I say, it's not a widely used tool, but I think if you're looking for something cheap and simple, then I wouldn't rule it out. And if Nicole and others have used it and it seems to provide a useful indicator, then we should, should listen to that evidence and experience.
Yeah, so I've got some grower groups using it with some of the trials and demos that they're doing. And yes, they're just using it really as a monitoring tool to measure the health of the plants. And that the theory is that, yes, so that when the when the bricks is at a certain level, I think it's, 14 or 15, then it's sort of optimum plant health, and that the plant can, resist insect attack and tolerate some, perhaps disease or fungal attack. It's really just a measure of plant health, perhaps. But yes, you could also use it to perhaps evaluate some of those treatments. But like Richard said, I think it's about replication and randomisation and consistency when you're doing that sort of thing. So yeah, thanks, Belinda. Yeah.
Just to add to that, I think the thing in using that though is you have to be conscious of, in the morning, bricks levels are going to be lower than in the afternoon and that kind of thing. So it's not a be all and end all test, but it's a way to, if you can get some level of consistency, to just be checking in on what's going on. It gives you just a kind of instantaneous measure of your plant health, or, how they're actually going. And anything from lack of moisture is going to drop that, or, there are other variables that you've got to take into consideration, but it's just is something quick and easy that anyone could go out in the paddock and have a look at.
Yeah, great. Thanks, Belinda. If anyone's got any other questions or comments for Belinda, please use the chat box, but we'll move along. Callum, have you finished your lunch now? Good job.
Yes, I have now. I'll start off with a bit of an apology because this probably isn't ready to be shared yet, but I'm kind of excited about it, so I'm going to share it anyway. So I'll put some stuff up. I'll share my screen. I've got some stuff in Word documents and stuff sitting there, so I'll provide some context. Let's see how I go. Oops, that's not what I want to share. I've made a mess of it already, sorry. All right, we'll start off with this one. So I just wanted to talk, obviously, I haven't had a lot of field work going on with the current situation, so I don't have a lot of interesting stuff to share. So I thought I'll share this little project that we've had happening over the last year or so. It's actually a farmer-driven collaborative research project that involves Murdoch, a associate researcher from Murdoch, some people from DPIRD, Land Save Organics, which is a business based in Mandurah, I think, and us and 3 of our growers. So it was a little pilot study, nothing too fantastic, and if anything, it's probably given us questions rather than answers. And we're looking at a trial brewing and applying compost tea to wheat crops, and looking at what results that gave in terms of NDVI, yield, net return, as well as sort of emergence and plant health. We need to do a lot more research. It highlighted several large issues with the way that the trial was run. But hopefully what you can see now, and someone tell me if you can't see table 1.
All good.
All good. So this is just the 3 that were set out. 2 of the landholders wanted to set up their own trials, which is A and C. And the second farmer set up his trial in partnership with Murdoch. So, I mean, it's fairly self-explanatory. They were decent replicated trials, around 6 hectares for each, looking at a nil strip, which was absolutely untreated, seed the wheat, see what happens. A conventional treatment, which was their standard application of Flexi-N, and I think actually they just put Flexi-N on this one, sorry. And a compost tea application, which was actually made on the property by the landholder, which in itself turned out to be a bit of a problem, because the first lot he did had absolutely no microbial activity in it. So that had to be reapplied, which unfortunately kind of messed with the net profit numbers at the end, which I'll talk about when we get there. The first interesting thing that came up was the original monitoring of the site. We did some soil testing and found that, hopefully you can see that,
Yes.
which is a fairly common sort of panel for our area, to see an excess of phosphorus and nothing else. We're not quite sure what happened here, but we're not going to complain too much about it because anything that's not deficient is great. So we weren't really able to quantify a lot of the relationship between compost application and some of these elements and the nitrogen fertilizer in some of these elements. I'll show you in a second. There did seem to be some correlation, but because it's a simple single trial, we weren't able to actually quantify much of it. So the first sort of measure we did was just simple emergence counts. And well, I don't know, someone can probably explain this to me, but something I found very interesting is that I would have probably expected the emergence to be completely the other way around, based off sort of the information we were working off. We should have had, well, the conventional probably should have been the best emergence. It's interesting that the nil treatment site had such a good germination. We can't quite account for why that is, but that's another question that's been added into further down the line. If anyone has any suggestions for why that might have happened, I'd love to hear them because I am in the middle of putting this report together.
Callum, was the conventionally sown with like DAP or MAP or something like that?
My understanding is that it was just his standard Flexian application. So I don't think so.
And not close to the seed, like you don't think there would have been a seed? Yeah, that's what Richard's saying, like a seed thing, not too close.
Possibly. It certainly is something we're going to look at. The people have suggested in conversation while we're putting this report together that potentially the delay in the compost treated seed might have been the plant focusing more on root development before its above ground biomass, which is discussed later on in the results in the NDVI readings, because the conventional had much higher readings than the compost, but weren't correlated with the yield. So there was a lot more sort of biomass on the conventionally treated stuff, but it didn't, the gap between biomass was much larger than the gap between the yield between the two treatments. And potentially, if it had been a bad finish, we might have seen a bit more of a gap. But as tends to be the way for the trial that we sort of wanted a not great finish, we got a good finish. So not much you can do about that.
And the compost was applied to the seed, is that what you're saying?
Yeah, so it was actually banded at seeding.
Okay.
Sorry, I should have covered off that. At some of the other sites, it was inoculated, as in the seed was treated first, but those sites, unfortunately, were the farmer-driven ones, and we don't really have any way of measuring what effect that had. You'll notice that there's some fairly large standard errors happening, deviations, sorry. Because we only had replicates at one site, it kind of, it messes that up a bit for us. The next sort of little result we looked at was some plant nutrient analysis. which I can't find now, sorry. So this one here. So it was interesting that in the, obviously all 3 sites were still deficient for nitrogen and potassium, which is, there's not much you can do about that. Interesting that you'll note the compost had slightly higher readings for both of those. Probably of some interest is that phosphorus element there, but I suspect that there's probably some explanation with nitrogen tying up phosphorus or availability there. I haven't really looked into that yet. And sorry, this is not very high quality, but I'm sort of in the middle of putting it together.
That's good. Good to see the early bits of it.
Yeah, so the yield stuff is particularly interesting. I had all these set out and I've lost them all now and it's terrible, sorry. So the yield actually wasn't fantastic for the compost treated trial. And this is in part why we looked at net profit as well as simple yield. This number here is not actually quite right. It was slightly higher than that. And it is barely statistically significant, the difference between these two. I mean, we would expect in the first year of any trial like this that there's a bit of nutrient mining going on. And so the intention is to extend this out to years 3, 4, and 5 to test what's happening there. The interesting thing for me that come out of that was the net profit. So the cost of the compost being so low meant that when compared to the traditional treatment with the nitrogen, the net profit come out $18 a hectare higher for the compost treatment than the nitrogen. So obviously this is where that where nutrient mining plays a big part. So that's the next thing that we want to quantify, is to make sure that this isn't just simply nutrient mining and we're going to end up with massive deficits in sort of yield, profit, and obviously soil nutrient in years 3, 4, and 5. Obviously in the nil treated site, there was also some additional net benefit with not applying nitrogen, but you know, you can say without a doubt that that is nutrient mining happening there. So, you know we can't just grow a crop from nothing. We did do some sort of anecdotal stuff in that as well. We talked about before the plants putting their effort into below ground growth before above ground growth, and we did see that gap close up as the year went on. It become harder and harder to see the difference with the eye. Obviously NVDI is a bit different, but with the naked eye it was very difficult to see the actual difference between the compost treated and the traditionally treated site a lot later in the year. All 3 of the farmers sort of were, I won't say disappointed, because they were very happy to have a good year at the end, but were sort of, I think, a little bit miffed that they didn't get to see what difference the compost treatment would have in a harder finish to the year. And that'll probably play out, you know, if this does eventually make it to being a 5-year trial site, at some point we'll probably get a chance to look at that data. And yeah, so like I said, it's pulled up a lot of questions. We are planning to do trials further to that, including moving to a glasshouse trial, particularly to focus on that chemistry side of it. But as with all things, it depends a lot on funding and where we go from that. And that's about it. I will say that another outcome from this project that wasn't intended but has come about from an initial failure with the first lot of compost tea is that Land Save Organics have actually developed a procedure and a guide for any land manager or any person actually that wants to produce their own compost brews. It's titled something creative like procedure for making actively aerated compost brews. No one's strained any muscles on that one, I don't think. But it is a good thing. Hopefully it will stop a similar mistake being made for the next person that wants to try it. And I will finish there and apologise for the lack of coordination in that data, but I haven't got anywhere near actually putting it all together as a report yet.
That's okay, Callum. It's good to see the start anyway. I think it's quite an interesting topic. I've got some landholders trying similar things, and there are some different theories out there around suggesting that the use of composts or worm castings or any of those sort of perhaps organic products aren't necessarily a replacement for nutrients, although the idea is that you might be able to put a lower rate of a starter fertiliser on and use these products to try and stimulate a bit more like root biomass and beneficial fungi and beneficial bacteria in the soil to release nutrients and cycle nutrients. So yeah, my only suggestion would have been that it might have been nice to see not just the compost on its own, but like a starter fertiliser and the compost together, like just to see if that was sort of a beneficial, yeah.
Sorry, I should have been a bit clear about that. There is a trial plot that looked at the 60 litres per hectare of the compost tea as well as a fertiliser application, but I don't have the data for it yet, so I didn't touch on it.
That's okay.
And also, probably something else I should have mentioned is that all three of these farmers have actually also applied it to their entire property. But obviously we haven't measured any of that, but they've sort of, the cost of it's so low. And I think once they've sort of made the investment into setting up that infrastructure, they might as well.
Yeah.
So it'll be interesting if we could to get some more money and go back and look at that on that broader scale. But yeah, it raised more questions than it gave us answers, that's for sure.
Yeah.
But that tends to happen. And you know, too, this is a grower driven project. So yeah, you sort of try and mold it to where you need it to be, but everyone has to be happy. So.
Any questions for Callum? Richard's asked a few questions in the chat box, but if anyone's got any other questions they'd like to verbalise.
I could just add, I thought you gave a really good summary, Felicity, that these products, if you look at the composition and rate, they're not fertiliser substitutes, but they're basically food for microorganisms. So you can stimulate release of nutrients bound in organic matter, and some of them contain hormones, so you do get some stimulation of root growth. But the other thing I would say is, keep up the replicated experiments with controls. That's the key. Without that, it's difficult to learn from these types of investigations. And I think we should all be out there trying to encourage this on-farm experimentation and inquiry, but it needs to be done with controls and replications so that we're not going to be misled by the results.
Yeah, and that's something that come out of this too, because incidentally we've done 2 bar widths, 37 metres for the plot width, and then a full run of the paddock, which they worked out to be about 6 hectares per run. But it meant that we had, we could sort of sample in the middle of those runs and avoid sort of any edge effects as well, which was something that become very clear at one of the other farmer sites, is that they had done a single run and you're sort of on the edge, you get this, you get an edge effect, and it makes already not very clear data even less clear and very confusing. On a couple of your questions there, Richard, the fertiliser was running pretty close. Karoo's mostly a pale sand. The site B has a little bit of a sort of a red sandy loam through there, but the actual triacer itself sits in a pale yellow, what would probably be classified as a sand, probably under that 5%. And Margaret Gallagher, who's an associate researcher, I think. Not sure exactly what her association is, but I mean, I could find out fairly easily.
Okay, thanks, Callum. We might keep moving along. If anyone's got any other questions for Callum or comments, please use the chat box or catch up with him after we've caught up today. Nadine, have you got something you'd like to share? You're on mute, so just unmute yourself. Or I can mute that.
Yeah, so I just wanted to, I guess, talk about one of the projects, well, the only project Morawa Farm Improvement Group does, because we're small and all volunteers. We got some of the Smart Farm funding from the federal government. And the idea was, I'm just going to show you photos as opposed to like a presentation, if I can do this. And if I can share my screen. That work at all? It doesn't look right, does it?
No, not yet. So the share screen's down the bottom, and you just got to choose the screen you want to share.
Yeah. I have to choose the screen I want to share. Okay, that makes sense. Oh, no, not that one. Oh, yeah, what happened? Put that in. Oh, what am I doing wrong here?
So click the share screen, and then all the screens sort of come up in a bit of a box, and you just choose the photo, just click on the delay.
Yep.
Cool.
Is that allowing a photo?
Yeah, it's good.
So I guess following on from what Peter was saying about how many growers are doing subsoils, in Morawa, lots of people do 0 to 10, have done for a long time. Down to 30 is becoming more common as we look at pH, but the farmers themselves are rarely doing that. They're getting a contractor or their agronomist to do it for them. So our thoughts were, we're not seeing what our soil looks like, and our soil is so variable that I think just getting the numbers back from your agronomist about what your soil looks like wasn't telling the whole picture. So one part of the project was we wanted to really see our soil and get deeper than 30 centimetres. And we wanted to, I guess, get some workshops around that, because we haven't had a lot of extension. We're considered too far away from everybody, so we don't get many visiting, I guess, researchers, until we started to be more active and invite them, and we get really good support from our Department of Primary Industries in Geraldton. So we basically bought this machine, got it modified so that it can go on any farmer's utes, and the idea is we just share it amongst ourselves. Any data goes back to Department of Ag in Geraldton. At this stage, they're not doing anything with it, so to speak, but it's just about making sure we can access that info if we want. And we had a series of workshops that looked at soil compaction and pH and a few different issues. Deep ripping has been used a lot, I guess, through the sandy areas of the Midwest for many, many, many years. There is now people looking at deep ripping compaction in loamy or clay soils, and this is not ideal in most of the cases because the soil types just aren't suited to it. And I think the reason people are trying is because there's probably a few consultants, farm consultants, that are pushing it unnecessarily. And there's this, I suppose, frustration is, it's really hard to grow crop. I want to do something, and deep ripping is something that you can do. And yeah, sometimes I think farmers think, well, I better do something rather than nothing. So our workshops talked a lot about when to rip, when not to rip, trying to get the message of use your machine, dig first before you start making a mess. So yeah, this machine basically hydraulics, pushes a core down to a meter, and then you can look at your soil. So this is just an example one. Is that screen shared for you now?
Yes.
Can you see a soil?
Looks terrific.
Yeah, so for example, in this soil, we can see that it starts out as a sort of loam, and then about 50 centimetres down, we're hitting what we call coffee rock, like a calcareous layer, and the roots can't get past that. So the benefit of having this machine was then now each farmer can see what is under their soil and know that, oh look, I've got a constraint there, a physical constraint, and make adjustments accordingly. Because had I just sent out the agronomist to do my soil tests and come back with nice numbers for me, I can't actually see that. And the previous generation, they put a lot of fences in, they dug a lot of holes, they knew what was going on. My generation and younger, we don't like sheep, we don't put fences up, and we probably didn't know as much about our subsoil as previous generations. So yeah, I just wanted to show people that's what we've been up to. A lot of people in WA have probably seen those hydraulic machines, but they're very useful, and hopefully we can continue to share it between ourselves for the next 10 years or so. Should last a long time.
That's great, Nadine. Yeah, Felicity was just wondering, is that what you spent your Smart Farms money on, as well as the workshops?
Yes. So basically, a proportion of it was the machine and getting it up and running, and then the workshops as well. Yep.
Yeah, great. Terrific. Did someone local build it for you?
The machine itself comes from New South Wales, and a local engineering company in Geraldton made the tray set up for us.
Yeah. Okay, terrific.
So can I ask, Nadine, what sort of funds did you need to do that?
Yep, so the machine itself, without getting out my paperwork, was about $7,000, I think. And then it was another 2 or 3 to get the engineering of the trailer. Yeah, so it ended up about 12, I think.
Great, thank you.
There are a few around WA. The Leby Group has one, which is where I got the idea from. I believe Farm Improvement Group has one. Yeah, there's quite a few around the place.
Great. Thanks, Nadine. Yeah, if anyone's got any other questions for Nadine, just pop them in the chat. It's really good to see that, the farmers getting out there and having a look a bit deeper and managing, adjusting their management, and you are sharing the same deep ripping concerns, I guess, that I mentioned at the start of the meeting as well, that farmers coming up against some compaction issues and just going out and deep ripping without perhaps looking a bit deeper to make sure that they're not bringing up any issues that might affect, maybe worse than just what the compaction is causing the plant growth. So that's really good. Excellent. Kylie, are you there? Would you like to go next?
Sure.
Great.
Mine will be fairly brief because we're not actually doing a lot of soils projects at the present point in time. So one of the things I should say is grew up on a farm, but I have no background knowledge in agriculture at all. So most of my learnings come from basically 12 years of going to crop updates. Oh, there we go, slideshow. Obviously, one of the biggest constraints for us is the availability of lime. We had a study done in 2015 looking at the economic benefits of liming, and basically through that we were able to get funded this on-farm lime extraction guidelines and this was looking at, well, what's the availability for lime, how do the economics stack up, and can you look at on-farm lime sources, particularly along the south coast. Whilst lime isn't hugely expensive, the transport costs to get it, especially to somewhere like Esperance, are quite high. So this is available on our Climate Action Farming website. The document's divided up into 6 sections, basically a whole heap of checklists and questions for farmers to go through and ask themselves before they start looking at on-farm lime extraction for their property. I mentioned the Climate Action Farming website. That's where that's available at the moment. As you can see, it's pretty dated. I should add, one of my real key interests is looking at how we extend information. So I'm really interested in trying to translate the science into something that people can understand out on the ground. I think, a lot of our land managers are far more switched on than I am in this regard, but yeah, there's certainly a lot of people who may not understand everything that we're doing. As you can see, this website's a bit dated, so we're just going through the process of updating that, and we'll rename it to Southern Soils, and obviously soils will be a fairly big component of that. What we're trying to do, rather than reinvent the wheel, is just make this a place where people can come and find the links that are relevant to the south coast of WA, and really just translate some of that stuff into what it means for these areas, rather than repeat what's actually already out there. I'm also particularly interested in trying to extend soil information to small landholders, and have been trying to put together a package for small landholders, particularly in our Esperance area. Right next to Esperance, we've got the Lake Warden Ramsar wetlands, which have significant issues with water levels, flooding, bird habitat, and so it decreases the amount of diversity. The adjacent land managers are typically small landholders. Typically they have, although this isn't always the case, limited agricultural knowledge, and so trying to target information at that demographic. And obviously soils will be a fairly major component of that. Still working on that at the moment. One of the things that we're playing around with is trying to do podcasts, and yeah, we've put together a rough one on rabbits as a bit of a proof of concept, and yeah, it seems to have worked fairly well. So watch this space on that. Yeah, any questions?
Thanks, Kylie. So the podcasts have worked well because people are listening to them, or they were user-friendly to sort of put together?
More that we haven't actually got to the stage of releasing it. We wanted to have a go at doing one as a proof of concept, just to see that we could do it ourselves. So all up, to do about a half an hour podcast, it took us about 5 hours. So yeah, not a huge amount of time, which is really good.
Yeah. And
most of that time was me refreshing my skills with the computer program. So I'd imagine next time around it'll be even quicker.
Yeah, I imagine with those things, it's the getting the script sort of ready to go, and the recording and stuff like that is, yeah.
Most of the time for us, it was the editing this time round, but yeah, we'll certainly invest more time upfront in doing the script and getting that together, which will cut down on the amount of time we need to spend editing.
Yeah, that's great. Any questions or comments for Kylie? Ray says, great work. Good. Excellent. No, it's really great to see the different communication tools that you guys are using, because yeah, we can all learn something a little bit different. And if you've got a repository of information that we can go to access and see what you're up to, then that's really great. Fantastic. Thanks, Kylie. We'll keep an eye on that and see, but have look with interest at your progress with that. That'd be great. Brianna, are you there? Would you like to go next?
Yeah, I've got something to share as well. It's just something brief on one of our projects. So at the moment it's been quite busy because we're at seeding time. We've got a few new projects trying to go into the ground, but this one is almost a year old and it's funded by the state NRM. It's looking at, hang on, I'll just try and bring it up. Can everyone see that?
Yeah.
Awesome. So it's improved grazing practices for improved profitability and better environmental outcomes. So it's a regen ag kind of project, but it's focusing on rotational grazing. So we've kind of found when you talk about regen ag to some of our growers, they start to have a little bit of a freak out and don't want anything to do with it sometimes. So we've kind of labelled this as a rotational grazing to show them that regen ag doesn't have to be scary. So the aim is for a long-term benefit to reduce the soil degradation from erosion and improvement in soil health. So it focuses on our really light sandy soils that we have around here. And it's looking to demonstrate to farmers that rotational grazing has both a positive and environmental and economic benefit, increase the adoption of rotational grazing, and to diversify and decrease erosion, water and runoff. So with this one, we have 5 sites or 5 different farms around our area. It's focused on perennial grasses. So we mainly focus on our panic and our Rhodes grass, which are common in the area, and they're normally located on our gutless sandy soils that don't really have much use. So this is one of our sites. This used to be one paddock. We've now divided it into 3 paddocks. They'll range from about 10 to 5 hectares. This one is on a backgrounding farm from a station owner up north. So with this one, they have adopted 4 days in each paddock, but depending on the amount of cows that they have in each mob, because it fluctuates with the amount of cows that come down from up north, they will change it as they go through the system. And with it, we are then monitoring. So there is 6 locations in each paddock with a GPS point. I then, at the end of each season, will go through and look at the perennials, measure the crown of the panic perennial, the size of it, and then the distance between each perennial from that, as well as looking at a quadrate, which is this one, and seeing what's actually growing between the perennials, that like the grasses, we normally get blue lupins or something else that's in the paddock. So this one was done in November last year, and you can see it's kind of got a bit of a cover crop, but the perennial obviously hasn't done much because we didn't have a large amount of rainfall last year. Our summer rain came through at the beginning of this year. At least we had something come through. And this was the April measurements that I took this year from the same paddock. You can see it's a lot greener with the perennials now. You can see though that a lot of the sand is still, you can still see the sand. So our aim is to try and cover this up as much as we can to stop the erosions. And that was from an April plant as well. So this is from another site. This site is further up, it's near Warradaji. So this site has a very minimal amount of grasses that grow on it even during winter. So it is just the perennials normally growing. This is the April time that we did this year, and obviously you can see the perennials have grown really well, but we've still got that erosion happening from obviously trampling, but the grasses just aren't growing in between the perennials. So this is actually just a plain panic. there was supposed to be an amount of rose grass in there, but we find that rose grass seems to have its patches that it'll grow, and then if the panic's high and that's at another site, the rose grass won't grow. This is Dandaragan Organic Beef site. So these guys have been doing rotational grazing for 15 years at least now. So they're one of our main sites that we focus on, and our other growers that are involved in this project use their knowledge to create a rotational grazing system for themselves. You can see these guys last year, they have a high amount of grasses that grow within their perennials, and they continuously rotationally graze 2 days, 3 days in each paddock. They've now downsized their paddocks, and with our rotational grazing system, we now do a 1 day rotational grazing through these 4 paddocks that we've selected. And this is the April one that we did. This one had been impacted highly by kangaroos. So originally these paddocks had been left out to set seed. But when I went through and did the rotational grazing, you can see that it's actually hasn't set seed, and most of it has been eaten by kangaroos. You can see these guys have also fenced their area off with an electric fence. So the funding allowed us to give each grower an amount of money to support their fencing. The water they had to do themselves, but the funding for the fencing is what they got out of it. These are what the perennials were supposed to be looking like in the neighbouring paddock, and they hadn't been eaten by kangaroos at this point, which is quite interesting. And you can see through the rows down here that the perennials have actually started to grow out. So this is what we aim to do with our other properties. We want those perennials growing outwards, covering this soil to stop the erosion from occurring.
Brianna, what are they doing there to encourage that? Why is it happening on that paddock and not on the other ones?
So with these ones, this is Dandaragan Organic Beef, and they have been doing this for many years. So they've always been rotationally grazing. So there hasn't been set stocking on this, and you can see that obviously the non-overgrazing has allowed the plants to spread out a bit more. So they pay attention to the amount of grazing that happens. So they do sit on these paddocks for 1 day to 2 days, but if they find that the grazing is having too much of an impact on the plants, they will rotate them out faster. They're actually paying attention to the biomass that is there instead of the animals at the same time. So yeah.
Yeah. It's I've had these conversations with graziers as well about you lock the paddocks up and they just get eaten by rabbits and kangaroos, so you're just fighting this battle against the other wildlife at the same time. So you mentioned a bit about cover cropping. Are they so with slide 17, would they go in and try and grow something else between those rows, or is there just not the rainfall to support it?
So this is in Dandaragan, which has a real high rainfall area. These guys have actually just purchased a disc seeder and are looking for the winter periods sowing in between the rows. So this is something the growers have shown a lot of curiosity, and we are looking to do a project on eventually, is actually seeing what we can grow in between those rows for a winter crop as well. Because the perennials, you'll find obviously in winter don't grow at the amount that they're supposed to because of the cooler season change. So they don't have the amount of feed in them that you would like. So to be able to grow something else in that paddock during that winter period would be extra beneficial.
Would that be for grazing or for harvest, like grain?
These guys might use it for either harvest for hay, or they'll use it for grazing. I've found that we've only got one of our growers that is actually a mixed farmer. So he does the cropping and the livestock. The rest of our growers seem to be full livestock. It's a bit harder to get some of our mixed farmers into the rotational grazing system.
Yeah, Callum's wondering if you've done any weight gain or cattle weight measurements to quantify changes in that respect.
It is something that's come up in the past, but because this is a project that is mainly focused on the cover of the soil and decreasing erosion, increasing organic matter over the soil, it doesn't actually lead to that side of it. Eventually, we will hopefully go further with this project and have more growers that want to be involved, and maybe if we can get more funding, we can look at that side of it.
He was wondering if Annabelle Coppin was involved.
Yes, she is. So Outback Beef is her property and we've got them involved. They were actually looking at decreasing their paddock sizes already, so we just helped them along the way with a bit of extra funding for their fencing.
Great. Terrific. Sorry, I've been monopolising the questions. Any questions from you guys? No. It's certainly something that's topical, and we've been doing lots of grazing workshops and stuff like that in Victoria too. So all about trying to maintain cover. Yes, Peter?
I thought I'd throw a question in. Yeah, I've been running a sort of, well, supporting a small grazing group, and initially it was just an agronomist and a animal health or expert person involved, but last group we had were more interested in soil health, so I've sort of put my hand up to do a bit of soil stuff. But just wondering, I've just been going through the Graham Sterling text that I've got, which covers a lot of soil stuff, but wondering if anybody's got a good text on the benefits of grazing management on soil health. So I think, in theory, we have, we expect rotational grazing to sort of improve the soil, but I was just wondering if there was any particular case studies or documents that people have seen that sort of actually demonstrates that. So I just know that I read one recently by FertCare that they put together something as far as climate change goes and increasing soil carbon, and as Richard sort of said before, that they sort of say that in theory you would expect a lot of the rotational grazing, and I certainly did, to improve soil carbon, but then when it comes to the research behind and demonstrating that, there doesn't seem to be much of it around. Yeah.
So no.
So what I trying to find the research to actually say yes, this is going to work is quite hard to find. Even with this project, so the whole aim of this project is to create also a better environment for our perennials to grow and increase the amount of feed that we can get from our perennials without overgrazing them. You can't really find much data on it. I asked around, DPERD gave me a little bit of information on a project they'd also done like this one in the past, but there was no real conclusion that came out of it. If anything, they reckoned that grazing the perennials this way was not beneficial.
Not beneficial for what? Sorry.
Not beneficial for the perennials. They reckon that they weren't going to get the biomass, like an increased biomass from grazing them this direction as such. But as for the coverage on the ground, there hasn't been much data that I've been able to find on it.
Okay. So I'm not sure if you guys have heard of Christine Jones, but she's done a bit of work on plant management, and I haven't actually heard her speak, but she spoke to one of my groups. And she shows a slide of a plant, three pictures of plants and at their different grazing levels, and just showing that, if there's not much on top, then the roots have been pruned, and if you've got a bit more plant, then you're going to have more roots, and if you've got this much on top, then you're going to have, this much root underneath. So she's talking about managing grazing so that you can maintain some sort of root matter underneath the soil, so you're capturing sort of carbon below the ground. And she's saying that grazing management results in, so eating it off the top results in the roots sort of sloughing off or falling off the bottom, entering the carbon system, cycling nutrients, feeding both, that sort of thing. So I guess, I'm just sort of letting you know that's sort of, perhaps Christine Jones has got some more information in regards to that and has maybe collected some data, but I'm not sure. Peter, have you heard her speak before or read any of her work?
No, I've only heard her speak once, which was the original Talking Soil Health conference back in 2012 or 13. Nothing since then, but yeah, sort of those types of things you can find that easily enough, but at the end of the day, all it is a photo of 3 plants. Sort of like, you'd hope to have a little bit more than that.
So no actual data, which is what I thought she might have had. Okay, that's interesting.
Well, not that I know of, but I haven't really looked into it that much. As probably other people know a bit more about her work.
All right, well, we'll see what I can track down. If anyone else comes across anything, it'd be wonderful for you to share. That.
Something I picked up at uni, one of the tutors has done work in the boxwood grasslands with farmers doing rotational boxwood. What is it? It's in Victoria. Communities in Landscape. Does that sound familiar? I'll see if I can find some stuff, because they sort of did a agroecology, he called it, and tested over I think a couple of seasons, and they found soil health improvement as part of their findings. So that might be something that helps, Peter. But I'll find some names for you, Felicity, so you've got a bit more to go on.
Actually, now that you say that, I did just recall one that Cole Sison, I think it was University of Sydney, might have been involved with, which did a couple of things, and I can't remember if the grazing management part of it, if they had a lot of data on it. I know it was a focus, but I can't recall what the results were, whether there were many, great results on the grazing management side of it. I think they also looked at a couple of other things, but yeah, that's one I'll have to try and dig up again.
Okay, great. Just writing that down. Terrific. Okay, Felicity is lucky last. Thank you for waiting patiently, Felicity. And thanks to Felicity again for her contribution at the National Soil CRC Community of Practice workshop and sharing the Regen Ag stuff that you've been doing. So, thanks, Felicity. Over to you.
Thank you, Felicity. The things are progressing with the CRC regenerative project, and that's it's really positive. So it looks as though we're currently honing in on the sites that will be looking at how carbon is functioning in the regenerative systems with pairwise comparisons to nearby farms that are under conventional management. And it's looking very much as though in WA we will have 3 regenerative farmers, McAlpine, Kelly and Haggerty, who have, and we'll be accessing properties nearby, where we've developed the criteria for selecting the regen farms themselves, and also how we're going to match the sites, and we've decided to use plots. So what we'll be doing is we'll be looking at 25 by 25 metre plots within types of soil that each of the regenerative farms have, where they have experienced the largest change when in their regenerative journey. So, for example, Stuart McAlpine talks about an area on his property that has very heavy clay, and it was extremely sticky. If you took a handful of this soil, it would stain your hands. And since he has been using biological amendments, that soil is no longer sticky. It comes away clean. It's changed quite dramatically. So what we will do is we will then find another site on a conventional farm where that sticky soil is, and we'll have a look at what how carbon and and microbiology and various things are working in both systems to try and get a handle on it. So that project's coming along. We'll be out we're trying to finalise those site selections so that we can get out and do emergence surveys in the next few, in the next 3 to 4 weeks. And then later in the season, we'll be doing biomass, we'll be doing some tissue testing, some grain sampling. And then finally, because we missed out on doing the soil testing this year before seeding started, we'll do it at the end in April or thereabouts next year. So it'll be very interesting to see what results we get, because we really don't know what they're going to look like because so little of this work has been done. We are sampling to a metre for the project, so we'll be doing 4 different strata levels, and they'll be tested for a range of things. So that's happening on that end of things. The other soil testing is very much part of my life at the moment, because it's not only that project, there's also 2 others that we're doing that is currently about soil testing. So it was really good. I really enjoyed having a look at that rig, because my staff ended up getting sent out to a farm yesterday to soil sample to 60 centimetres with a hand auger, and I've got 2 very, very sore young ladies today who don't like me at all right this very minute. But that project is about maximising fodder options within mixed farming systems, and what we're doing is we're working with Phil Barrett-Leonard, who's well known over here as something of a pasture expert, and he's looking at, we've got 12 farms participating, and they are sitting down with Phil and talking to them. They're all mixed farming systems, so they're talking about their production goals, particularly with respect to livestock, but and etc., and trying to work out how we can not only maximise ground cover on their farms, but at the same time we can also be providing fodder that reduces any reliance on bringing in feed, supplementary feeding. And we've got an economist working on the project as well, so that the farm plans that are developed, we will start to implement those plans, but we'll also be modelling on what it's actually costing the farmer to put these plantings in, and then what return on investment they're seeing in the life of the project and what's projected for the future ongoing. So that's a really interesting project. All the farms participating are quite different. We've got one cattle farmer. We've got mostly sheep, but we've got a cattle farmer. We've got some that are multi-species animals. We've got the Kellys participating in that project as well. So we've got one regenerative farmer in the mix. And the plans are just starting to, we're just starting to see the final plans come out now, and they've mapped the whole property and demonstrate where the plantings are going to be. So what we're doing right now with the soil sampling is we're particularly looking at carbon in areas that will be planted with perennial plantings. So we want to find out what carbon is existing in the soil now, and then ultimately at the end of the project whether there's any change. So it was really useful for me to hear about how the amount of clay in the sandy soils, because so many of these properties, those areas are really sandy. So, so I've been away in lunch break and made sure that we've got some testing in there to determine what the clay content is in all those soils, so that we can have a look at some of that data and see that if we are seeing changes in soil carbon, does it relate to the amount of clay that's in the soil. So that's that project. And the other project that, again, you know, it's been very interesting for me for aspects of the conversations that we've had today. That project is about applying compost. So for those who were at Talking Soil Health, you may remember the farmer Rob Grills, who did a presentation. He's been working for a number of years on trying to incorporate composts and compost teas into his system with a mix of starter fertiliser and natural organic products. So he's currently out at the moment, busy seeding. He's drilling seed in with pelletised chicken manure, and then he is spraying a liquid fertiliser starter over the top. But he's got a plot trial established, and and that's the basic mix, and then he's modifying the amount of chicken manure pelleted fertiliser he's applying, and the amount of starter non-organic fertilisers, and he's playing around. He's using some teas and things like that. So it should be quite interesting, because we've got 4 different application rates and a control. So it'd be interesting to see what comes out of that project. So, but he hasn't used this particular product before, so we'll see how it goes. And that's pretty much at a wrap what my team's up to at the moment. But I have just purchased a hydraulic. Well, it's at least a diesel powered corer from Christie's Engineering, because I couldn't quite find 12,000 in the budget. But now that I've eyed off that Morrowa system, I think I'm going to have to I'm gonna have to look at save up my pennies and upgrade again, I think, because it's saved so much money. We've usually, we have traditionally, when we've done this work, we've sent out experts to do it in the field. And of course, it's so expensive to do it that way. It just chews through your budget. If we can do it with our existing staff, we're absolutely, streets ahead. So that's definitely something that I'll be looking to do in the future.
Yeah, great. We've got one of our groups has got a soil corer on a trailer, so that's another option rather than sticking it on the back of a ute. If you put it on a trailer, then it means that anyone can use it, or you can. So we've got a landholder group who use it regularly and share it to other groups as well. So
I'm sure that I mean, we would have been very happy to have hired, this sort of thing if we'd been able to find out where where you could hire it. But we weren't successful in finding anyone. I note that Nadine has said in the chat that that the sampler that they're using is a Christie's product too. So my understanding from all of the networks through the CRC that they're very good, these rigs.
And the problem with borrowing or hiring is that everybody wants to use it at the same time. So unless you're prepared to sample at a different time than when everybody else is, it can be a bit tricky doing that. Sorry, Nadine.
Well, that's very true.
Yeah. I was just going to say, they do last a long time. Levy's had theirs, which is the same as ours, probably 10 years, maybe even more, and it still goes great. The Department of Ag in Geraldton have theirs on a trailer as well. The reason we went for the, slide on and off was we didn't want the ongoing cost of rego of trailers and tyres. and that sort of thing. So ours actually goes off a ute and on a ute with forklifts or stands. So that was good.
Right.
But yes, whatever suits everyone. It's really good.
Yeah, that's good. Terrific. Thanks, Felicity. So we're just nearing the end, but I just want to open it up. Has anyone got any questions for Felicity or for anybody else that they didn't get a chance to ask a question? Or if Richard, if you've got any special comments you'd like to make about anything particular that we've heard today? Peter said he'd like to learn more about subsoil manuring, building carbonate depths, and may offer the best opportunity. Yes, so is there any work in Western Australia being done on subsoil manuring? I know that there's been a lot of work in Victoria, South Australia and Southern New South Wales, but I'm not aware of Western Australia, so.
Yeah, there has been a little bit. The DPERD have started. David Hall has some experiments. So, next time round, we could perhaps dig that information out and find out what they're discovering.
Right. So I know of the work that's being done in Victoria. So yeah, Agriculture Victoria has done a bit of New South Wales DPI through a GRDC funded project that's been going for I think 3 years now, and this might be the fourth year. And they've been using pelletised lucerne and some manures as well at depth, and they had special machines sort of built. It's just this trade-off between the cost of getting that product to depth and the sort of trade-off you get. But I can certainly get some of those East Coast guys to talk about the work that they've been doing, which might give you some ideas about the work that you might be able to do yourselves in that respect. Yep. Alrighty, so the only other things that I guess I just wanted to cover off before we finish up, and we've only got a few minutes, so but if anyone's got anything they'd like to say, please jump in at any time. I was just going to have a look at the paired, just to mention quickly the paired project. Oh, that's a list of so this is just the table that I put together for the paired project, and it looks like most of you have got yourselves organised, and Belinda and Callum, you two are left to sort yourselves out because everybody else has sort of jumped in, and I think Kylie and Felicity, you both had sort of suggested something similar that you might like to work together, so I've sort of popped you two together. But if you're not happy with that, then I'm happy for you guys to sort yourselves out. And I'm not against a 3. So if Belinda, you're interested in Regen Ag as well, and you want to jump in with Felicity and Kylie and work together in a 3, then that would be fine as well. So I guess I just wanted to, I'll send this out with the notes after today. Just wanted to give you a bit of a heads up on that. And I'm happy for this to be conducted over the next 12 months. It's just something for you to do that would be of interest, that is relevant to the work that you're already doing with your groups, and that will increase in your skills and knowledge, in an area of interest. And then you can produce something, whether it be a webinar or a paper or a fact sheet, that we can share amongst the communities of practice. You can then share with your groups and landholders. So I don't necessarily want it to be something extra, but it's something that you can do that will be supported by the community of practice, and you can tap into the soil CRC researchers to help you to put something together. So the idea is that you might work on it over the next 6 to 9 months. If you get it done a bit earlier, then you can present it to the group earlier, but just keeping in mind that this part of our project finishes up in June next year, so it really needs to be done by then. And also we've been talking to the Extension Oz people, and the Soil CRC has supported us to develop a portal using the Extension Oz platform. So if anyone would like to be involved with me in designing what that might look like, then I'm happy for you guys to have input. We can make it, if you go and have a look at some of the Extension Oz platforms that are already there, we can build it on something similar that's already been developed, or we can just keep it really simple. The idea is that it gives us a place to upload information, ask the Soil CRC researchers to contribute papers that you can see. It gives me an opportunity to upload these videos to a place where you can come back and watch them, or you can share them with your groups. And also gives you an opportunity, if you've attended a good webinar or seen some great information, that you can upload it to the site as well. So yeah, I'm happy for whoever wants to be involved in that process to come on board. So I just wanted to give you an update on that. And just before we go, I just went to a soil pit day, and this was something that I wanted to do with you guys when we were going to be face to face. And we'll still get to do it because I think it's still important. So when we all can travel again, we'll definitely get out and do something. But I just wanted to show you, I guess, a bit of the extension resources that these guys were using. So this is just showing sort of the dispersion test. I think there's a bit of topsoil, and then the soil just gets worse as it's at depth. This is, and I just wanted to show this example of the infiltration test. So if you look at this part here, and Richard, you might have some other comments to make about this, but what they've done here is really just created a bit of a dam around the topsoil and then poured some dye into it. So I think, Peter, you were talking about putting a ring down or banging a ring in and maybe disturbing it and it not being all that accurate. But what they've done here is just really just push the soil up to contain this solution, which is a dye, and poured it in and then just let it sort of seep through, and then they dig it back. Richard, have you done anything like that before?
Not personally, but I've had collaborators and students working with, I think it's mostly Brilliant Blue that people use. And of course on our white sands, it looks brilliant.
Yeah.
On the coloured soils, the red soils and darker soils, it's not quite as visual, but I think there's a nice, relatively simple visual techniques that can be quite illuminating to see where the water's travelling and the porosity of the soil, and yeah.
Yeah, so this was another site, and they've just used these tree planters that they've just sort of pushed into the soil and then poured the dye in, and you can see that it's come out of the edges. It's come out of the edges a little bit there, but you can see that it's gone down into this spot as well. Nadine, could you just mute your microphone, please? Sorry. So yeah, and this was a really rubbish soil where they were talking about deep ripping it, so I was a little bit worried. But anyway, I just wanted to show you those couple of things. Oh, this is where they were doing some deep ripping with this this tractor on this very open There was not much ground cover to it at all. That's what it looked like at the end. So, and they were deep ripping down to 30 centimetres, I think. So, yeah, anyway, I just thought I'd show you those couple of bits while we had a few minutes. I just thought that was a bit interesting. So there's a couple of comments there, Richard, from Nadine. Richard, you're working on a herbicide residual project? Yeah.
Yes, that's with Mick Rose. So we've got a PhD student who's just started on that, and a part-time postdoc fellow. So yeah, happy to. Yeah, I think Nadine, we did talk briefly when we met at Murdoch. So happy to keep in touch over that one.
No worries. Yeah, Nadine, I'll pop that down in my notes, and I'll write up the notes from today, and perhaps just give a little reminder for Richard if he could send through. And I guess Richard, just having considered what we've heard today and what the participants have talked about, I guess if you could have a think about the people in Western Australia who are doing the work, researchers or the like that are working on those topics that were covered today, and perhaps provide some feedback to the group of who they might be able to contact, or might be able to support them in that space. After today, I will write up these notes and send them to you. This has been recorded, so I'll send that. And because we're in this situation that we're in, I will put together a bit of a webinar program that we'll implement over the next probably 6 months. So I don't want to lose momentum of us being able to share information and not be able to cover off on the topics that you guys have identified in the capacity building plan. So we'll still be able to get together, and I'll just sort of nominate a time, perhaps in the mornings, and we won't go for as long as we have today. We'll just keep them a bit shorter and interactive, and I'll record them so that if you can't make it, you can look at it at a later date, we'll go from there. So yeah, unless anyone's got anything more they want to add, or always email me if you've later on you think of something that you wished you'd said or asked, then just send me an email. But if you've got anything you want to add before we close up.
Felicity, are we planning on once travel's allowed, if hopefully maybe by the second part of the year or early next year, are we planning on still doing all those, like going to the labs and doing those interactives, or are we now doing that all online?
No, I would very much hope that, we'll be able to get together, Freya, and yes, go and visit some labs and go out and do a soil pit and go and visit some of these great properties and landholders that you guys know about, so that we can get some hands-on stuff happening. So for sure, as soon as Western Australia lets us in, and don't have to isolate for 2 weeks before I get to see you, I'll be over there like a shot for sure. Yeah, no, that'll be cool. Yeah. Great. Well, thank you very much. Thank you all for contributing. I really appreciate you taking the time and sharing with us all what you're up to. And thank you very much, Richard, also for sitting in and sharing and supporting. It's been really great to have you on board. And I look forward to meeting you all again. But in the meantime, we'll keep connecting and keep sharing information. Like I say, I encourage you to email if there's anything that you think is worth us all knowing about, then email away, and we'll keep connecting and sharing. So I wish you all the best for the rest of the sowing and for the season ahead. And thanks very much, and stay safe. Wash your hands and all that. I'll stay on for a little while if anyone wants to ask me any questions after we finish. So thanks.
Bye.
Thanks, Richard. See you.
Thank you. See ya.